Open up your MTT. We're going to do an algebra final exam review. Alright, you're going to be asked to match equations to graphs. So let's take a look at some of our math strategies that we can use. The first thing we're going to do is look at our graph and see what information it gives us. The first thing that our graph gives us is that the y is going to be greater than or equal to. The shading you can see is above the line, and you have a solid line. So that gives us the greater than or equal to. The other piece that we're going to look at is we're going to look at our y-intercept. So our y-intercept is 0, 3, which means there's a 3 on this side of the equation. So the first thing that we're going to do is we're going to take a look at our equations. Now notice that the equations are not solved for y. However, we can do a quick little shortcut to see what's going to happen to the y and what's going to happen to the 3 when we do solve. You're going to notice here that this is a negative y. So eventually, after we zero pair out the x, we're going to divide by negative 1, and we're going to divide by negative 1, which is going to make this y is greater than or equal to negative 3. And we go back and look at the graph, you'll notice that negative 3 is not on the graph. So we know that that is not a possible answer. Let's do the same thing on the second one. Now in this case, we already have a positive y, so this equation is going to be y is less than or equal to something with x and then the negative 3. But again, all we're looking at right now is the y and the negative 3. The negative 3 is not on the graph, so we know that that is not a possibility. The next one that we look at is y is greater than or equal to negative 3. Y is greater than or equal to, we don't know what's going to happen with the x just now, but that's going to be a negative 3. Again, that's not going to be on the graph. The next one is going to be negative y, so again we're going to have to divide. Divide by negative 1, divide by negative 1. That's going to give us y is less than or equal to negative 3. Minus min, flip the sign. So that one's not going to work. And the last one, we're going to go ahead, divide by negative 1, divide by negative 1. That's going to give us y is greater than or equal to 3. So this is a definite possibility. But because there's always a likelihood that you can make a sign error, you want to do some double checking to make sure you have the right equation. Easiest way to do that is to pick a couple of points and test them out. So let's go ahead and pick a point that we know is on the graph. So I'm going to do negative 2, 1, 2, 3, 4, 5. Okay? Definitely way in the shaded area. So we're going to take the ordered pair, negative 2, 5, and we're going to see if it works. So we're going to go ahead and plug in the equation. So we're going to have negative 2, and that's going to be minus 5 is less than or equal to negative 3. Add a line, change the sign. Negative 7 is less than or equal to negative 3. So this is looking pretty good. We're going to go ahead and we're going to check one other point. It looks like we have an x-intercept here, which is going to be negative 3, 0. So let's plug that in. Negative 3 minus 0 is less than or equal to negative 3. Negative 3 is less than or equal to negative 3. That's a true statement as well. So I've got two true statements with ordered pairs checked, and I've already done my shortcut to see the direction of the sign. So I'm pretty confident that E is going to be my answer. Alright, let's try another one. Again, we've been given a graph and we've been given some inequalities to see and match. So what we're going to do is look at what the graph tells us. So when we look at the graph, we're going to notice that the graph is shaded below the line, which means we're going to have a y is equal to less than. We've got a solid line, so it's going to be less than or equal to. And we're going to look at our y-intercept. Looks like our y-intercept is going to be 1, 2, 3, 4. It's going to be 5. So let's use our shortcut and see if we can kind of eliminate some of our possibilities. So the first one that we're going to look at, A, we're going to divide by negative 1, divide by negative 1. So this is going to be y is greater than or equal to positive 5. Okay, well we do have the positive 5, which is good, but the greater than would mean that we were shaded on this side, which we're not, so that's not an option. This one is going to be y is greater than or equal to 5. Again, we have the y at 5 as the y-intercept, but the shading's on the wrong side. So B is also going to be eliminated. The next one's going to be y is less than or equal to 5. Now, this is a possibility because y is less than or equal to 5, so we want to take a look at that one. Then we're going to look at D. If we divide by -1 and we divide by -1, we're going to have y is greater than or equal to -5. Okay? Well, our -5 is on the graph, however, we don't have shading above the line. So that one's going to be out. And the last one is going to be y is greater than or equal to -5. Again, is one that we've eliminated. So it looks like C is going to be our answer. So of course what we're going to do is pick some points. So I'm going to go ahead and pick an obvious point that's over in the shaded area. One of the easiest ones might be 1, 2, both positive numbers. So let's take 1, 2 and see if it works. So 1 plus 2 is less than or equal to 5. 3 is less than or equal to 5. Okay, that's a true statement. Let's just pick one other point. Well, it looks like we have an x-intercept here. So that's 1, 2, 3, 4. So we have 5, 0. And we're going to go ahead and do 5 minus 0 is less than or equal to 5. 5 is less than or equal to 5. That's also a true statement. So we're pretty confident that C is going to be our answer. All right, a reminder here when we're looking at parabolas and the effects on parabolas when we change our functions. Remember that our parent function is typically at the vertex. We have 2, 1, 2, 3, 4, and 2, 1, 2, 3, 4 with our axis of symmetry. Okay, so there's our parent function, and what we are looking for is what happened to that function. So we're going to have a y is equal to x squared, and notice that our vertex went up 2, so we're going to have a plus 2 is going to be our equation. Again, if we look at our parent function, and we're looking to see what's happened to our parent function, here's where our parent function would be, and you're noticing that y is equal to x squared. It's moving up and down on the y-axis, so it's going to be minus 1, 2, 3. Minus 3 moves that whole parabola down 3. Now, when that parabola moves on the x-axis, that means that something is happening inside of a parentheses. So we're going to go ahead and set up that parentheses, and we're looking at both graphs, and we're noticing that it's moving on the x-axis for both of them. That means the square is affecting the x after a math operation has been done to it. So our parent function is here, and it has moved 1, 2, 3 to the left. But we know that the sign inside of the parabola is going to be just the opposite. So if this is -3 to the left, then it's going to be an addition sign inside. Similarly, we have our parent function here. Oops. And what we're looking at is it has moved 1, 2, 3, 4, 5 to the right, which means there's going to be a negative sign inside there. All right, this is our parent function, so it's going to be y is equal to x squared. And notice our parent function, but all that's happened to it is it's flipped over. So it's going to be -1 times x squared. Here we're going to be finding the smallest value of f in order for c to be greater than or equal to 70. So the easiest way to do this is to go ahead and substitute in your 70 for your c. So 70 is equal to 5/9 times f minus 32. Now what we're going to do is we're going to go ahead and get f on the left. So we're going to do 5/9 times f minus 32 is equal to 70. We're going to get rid of the 5/9 by multiplying by 9 over 5, multiplying by 9 over 5. That's going to cancel that out, and this is going to leave me with f is minus 32 is equal to 630 over 5. So we're going to go ahead and simplify that fraction. F minus 32 is equal to 126. Add the 32, add the 32, and we're going to have f is equal to 158. In this question, on 25, we're looking at a rate of pay that